Hello guys, now let us move to the another problem, that is we have to derive the mean and variance of Poisson distribution using MGF, uh, that is a moment generating function. So let us derive. The first question is nothing but derive mean and variance using variance of Poisson distribution using MGF, that is moment generating function. So we all know that so let us derive this step one by step. So what is the moment generating function? So moment generating function can be indicated with mx of t is nothing but the expected value of e power t power x. So we all know that we have to find for the Poisson distribution, right? So what is Poisson distribution? P of x is nothing but the e power minus lambda power x by x factorial. So let us make a note, that is sigma x is equal to 0 to infinity Rn e power t power x into p of x. So what is p of x? X is equal to 0 to infinity e power t of x into p of x is nothing but the e power minus lambda into lambda power x by x factorial. So just be careful while doing this sum, because we have many lambda value and many x values. So later you might get confused. So now from now onwards, just clear it. Just I will be slow, so you also watch the video slowly, so don't get confused. Okay, so now let us move on. So here this term is constant, entire term is constant. Now what is the power? So we have x power x and t power x power t power e power t power x. So let us merge these two values, that is sigma x is equal to 0 to infinity. So y, that is lambda into e power t whole power x into e power minus lambda by lambda. So let me write this step again. So I will make a note here, that is sigma x is equal to 0 to infinity e power t power x into p power x. So what is p power x? Sigma x is equal to 0 to infinity e power t power x into e power minus lambda power x by x factorial, right? So here x power is common. So now let us combine the base values, that is sigma x is equal to 0 to infinity e power t into lambda whole power x into e power minus lambda by x factorial. So we know that this term is constant term. So let us bring outside e power minus lambda sigma x is equal to 0 to infinity e power t into lambda whole power x by x factorial. So in 12th standard we have learned that since z power x by x factorial is nothing but the e power x. So if you remember this value, if you remember this formula, we can write this as, that is e power minus lambda into, so this term is nothing but the z term, we have x power by x factorial. So then we can write as e power this term e power t into lambda. Hope you got it. So now let us get out the y term common, that is e power lambda of, we'll be getting e power t minus 1. So how did I do? So I have taken the y term. We know that bases are equal. So if bases are equal, we have to add the exponential, right? So that is the reason. So bases are equal, so we have to add this. So when we take the lambda value outside, we'll be getting e power t minus 1. So that is the step. So what did we get the mx of t value? Mx of t is nothing but the e power lambda into e power t minus 1. So this is the moment generating function of Poisson distribution. So now let us move on to the finding the raw moments. So raw moments, that is first one is nothing but the mean. So we'll be getting mu1 dash is equal to mean. So what is mean? Mean is nothing but the first order derivative of MGF. So first order derivative, that is d by dt mx of t is equal to, so d by dt of, so what should I take, e power t or this one. So while looking at this we can say that e power t power n is, the entire term is constant, but we need the terms in the base values, right? So let me take this term as these two are common, these two are same, but I will be taking this term to solve the process because it will be easy for me to progress. So e power minus lambda into e power t into lambda. So we are derivating with respect to t, so entire term without t is will be constant, right? So e power minus lambda will be getting outside, so we have to derive with respect to t, that is, so d by dt of e power t into lambda such that t equal to 0. So how we should derive this, so I will be explaining now. So now consider, so we have to derive for this term, right? So let us consider that is m is equal to e power lambda into e power t. So this is the term, I am deriving it here shortly. So we have considered this term as here. So now let us let y is equal to e power t. So then how we can write m is equal to e power lambda into y, right? So now let us derive this, differentiate this, that is dm by dt. So what is dm by dt? So if you remember 12th standard basic maths, so if you want to derive this one, we have two variables, that is first one is t and other one is y. So we have to derive based upon the two parameters, that is dm by dy into dy by dt. So if you remember that this is a step, so y term will be getting cancelled and we will be getting dm by dt. So that's so simple. So now what we have to do, we have to derive m with this term, that is this term, with respect to y term. So what we'll be getting, so we'll be getting e power lambda into y, and we'll be getting, we have to differentiate for the above power term also, we'll be getting y. So this term is completed. Now let us move to the dy by dt. So what is the dy? Dy is nothing but the e power t. So differentiation of e power t with respect to t will be e power t itself. So what did we get? So we get e power lambda y into lambda e power t. What is y value? Y value is nothing but the e power lambda, that is e power t lambda e power t. So this is the value we have got. So now let us substitute this value in this step. So we will be getting e power minus lambda into, so we have got this term, right? So we have to place this term here, that is e power lambda e power t into lambda e power t. So in exam, if you remember this process, just do it, or else you can if you want to make a note directly, so directly you can solve it here, so there will be no problem. So now what is the constant term here? So let me create the y. Let us take the lambda outside, lambda e power minus lambda into e power lambda e power t into e power t, such that t equal to 0, So what we have to find, we have to mean, right? So d by dt mx of t such that t equal to 0 is equal to, we have to place t equal to 0. So in place here we will be getting 0, here we will be getting 1. So what is the remaining term? By e power minus lambda. So e power t is nothing but e power 0, we will be getting e power lambda. Now here e power 0 is nothing but the e power, we will be getting 1, right? So we got lambda. So we know that e power minus in lambda, e power lambda will be getting cancelled and we got lambda. So what it is, nothing but the mean. So we got, therefore we got mean is equal to lambda. So we got mean is equal to lambda in Poisson distribution based upon MGF. So now let us find the variance also. So solving for variance is nothing but the double derivative, that is mu 2 dash is equal to d square mx of t by dt square such that t equal to 0. So we already derived the first order derivative, that is d by dt of d by dmx of t by dt such that t equal to 0. What did we get in first order derivative? So we got in first order derivative, that is this term lambda into e power minus lambda into e power lambda into e power t into e power t. So that is the term we have got. So substitute this term here, that is d by dt of lambda e power minus lambda into e power t into e power lambda e power t. So this is the term we got such that t equal to 0. So what is the constant term we are deriving with respect to t, right? So expect the t terms, the entire term will be, entire the remaining variables will be constant. So this term will be entirely constant, this term has e power t, and this term also have t value. So that is lambda into e power minus lambda will be constant. So now we have to derive for these two terms. So let us consider this as u and this as v. So what is the formula of dv? So d of u comma v is nothing but u dv plus v du, right? So let us try to find. So what is u? So u is nothing but e power t, u into dv. We have to derive this term. So what we'll be getting? So e power lambda e power t into lambda e power t will be getting, because e power x into e power x differentiation of e power x will be e power x into x. So right, so that is why we have derived it, we have written it. So now we have to find v du. What is v? E power lambda into e power t into what is the differentiation of e power t? E power differentiation is nothing but e power t itself, such that t equal to 0. So now let us substitute t equal to 0 in the entire equation. So we will be getting lambda e power minus lambda e power 0 into e power lambda e power 0 into lambda e power 0 plus e power lambda e power 0 into e power 0. So we know that e power 0 value is 1. So what will the resulting value? Lambda into e power minus lambda. So this term will be equal to 1, and this term will be getting e power minus lambda, e power lambda into lambda plus e power lambda. So this is the actual term we have got from the above solvation. So now let us take the e power. So if you can see in this equation, e power lambda is common. So get e power lambda outside. That is lambda into e power minus lambda. So what if we get e power lambda? So what is the remaining term? Y plus 1, lambda plus 1 will be the remaining term. So we know that e power lambda into e power minus lambda will be getting cancelled. So what is the remaining term? Lambda into lambda plus 1. So this is the mu2 dash value, that is lambda of lambda plus 1. So now we have to find the variance, right? So variance is equal to, we know that mu2 dash minus mu1 dash whole square, that is e of x square minus e of x whole square. What did we get? E of x square. E of x square is nothing but the lambda of lambda plus 1 minus, what did we get? E of x. E of x nothing but the lambda square, that is e of x is lambda, and we have to do it square, right? So let us multiply this, lambda square plus lambda minus lambda square. So what will happen? Lambda square will be getting cancelled, and we'll be getting a variance. Variance is nothing but the lambda. So therefore we got mu1 dash and mu2 dash as lambdas. So this is the actual process to find the Poisson distribution using MGF, that is moment generating functions, what we have discussed so far. So we have discussed the moment generating function based upon the Poisson distribution. In Poisson distribution we have derived the moment generating functions. What is p of x? P of x is nothing but the e power minus lambda into lambda power x by x factorial. So then we have derived the mx of t. So then we have derived the moments, that is the mean. So in mean we have derived the, so mean, just be careful before you solve this. So you will be getting confused. Most of them will be getting confused in this step. So if you get confused, just solve it beside and then write the formula in this step and substitute the e value, that is t value equal to 0. So you will be getting a mean equal to lambda. So then later we have to move on to finding the variance. Finding variance is nothing but the double derivative of the MGF. So we have to double derive it to get the variance. So then we have used the formula differentiation of uv, that is u dv plus v du. So then later we have substitute t equal to 0 and e power z is equal to 1. So what did we get? Variance mu2 dash is equal to lambda into lambda plus 1. So then later we are find the variance. So this is actual step. So this is the process to find the Poisson distribution using MGF. Thank you.